Welcome back. This is Module 2 of Rust crash course, Data Types and Control Flow. Think in precise types, safe control flow. That's the mindset shift this module is about. We're covering three things: scalar and compound types, enums and pattern matching, and finally option, which replaces null safety. Let's go. Scalar types hold one single value. Rust has four categories. Integers can either be signed or unsigned from 8-bit to 128-bit. i32 is the default and fastest on most CPUs. You must only specify the width explicitly. Rust won't let you be vague about it. And we have float, F32 and F64. F64 is the default, double precision, but there's an important warning. Never use the double equal to compare floats due to floating point representation. 0.1 plus 0.2 does not equal 0.3 in binary. We'll see the fix in the code example. And third, we have booleans. Bool is one type, either true or false. And we also have chars, which are character, is 4 bytes, a full Unicode scalar value. That means it can hold any character, including emojis. Here is the full integer table. This is your reference. You'll come back to this mentally every time you choose a type. There's 8-bit, byte, raw data, small integers from 0 to 255. This is unsigned integer. For positive number only, and signed integers also have the negative numbers. And we have i16, which is legacy systems, which are rarely used in modern code. And you have 32-bit, which can either be i32 for the signed, u32 for the unsigned integer. It's highlighted in gold because this is the default. It's fastest on most CPUs, and use it for general integers when in doubt. And we have 64-bit, i64, u64, large count, file sizes, high precision timestamps. 128-bit, i128, u128. This one is typically used for cryptography, blockchain balances, any case where you need to avoid overflow. And finally, architecture dependent, I size, U size, 32-bit on 32-bit systems, 64-bit on 64-bit systems. It's used for indexing, collections, and pointer arithmetic. If you're writing a for loop index or calling a dot len, the type is usize. Two rules to remember: i32 is your default integer, usize is your indexing type. This slide is critical, especially for smart contract developers. Let's talk about what happens when integers overflow. U8 holds values from 0 to 225. If you add 1 to 255, you overflow. In a debug build, Rust panics. It crashes with an error, which helps you find the bug. In a release build, it silently wraps around to 0. Same code, different behavior, depending on how you compiled it. That's dangerous if you don't know about it. The solution is to use explicit arithmetic methods that behave the same in both mode. And this is what you see here: X wrapping, add 1. This one, first one here, always wraps, returns 0 when X is 255. X checked at 1 returns none if overflow will occur. This is the safest option because it forces you to handle the overflow case. And then we have X saturating at 1. This one clamps at the maximum value. It returns 255 when X is already 255. The important note, in smart contract, always use checked wrapping or saturating arithmetic. Never rely on default overflow behavior. A contract behaving differently in production than in tests is a serious vulnerability. Let's look at this code. The float comparison is the most important thing here. 0.1 plus 0.2. In binary, floating point is actually 0.300004. So A equal 0.3 is false. The correct way to compare floats is to check that the difference is smaller than F64 crate epsilon, a tiny constant representing the smallest meaningful difference. The financial tip at the bottom says avoid F64 for money. Use integer types. Store cents as I64 to prevent precision errors. A smart contract that uses floats for balances is a broken smart contract.